Yeah. Uh, Welcome to the lab program session. In a lab program, already we have discussed the fourth program. What the fourth program we have discussed? We have discussed the multicast routing protocol. That program we have discussed in a last class, and I have told you that how a multicast routing protocol will be taken and how it will be differ from an ordinary unicast. That is, first you must know what is a unicast. Unicast is a single source and a single destination. Multicast means many, that is one source and many destinations, or many sources and many destinations, many sources to many destinations, like that it can be. So in an example of a fourth program, we have taken a three nodes, that is a N0 node will be there where packets will go to N1 and N2, where N1 and N2 are individual destinations, and we have declared the multicast routing protocol for that. Now, as usual, we'll go for the next program, that is the fifth program of your lab. So, coming to the fifth program, just I'll share this. Coming to the fifth program, 1 minute. Yeah, back here. Now I'm going to share the VMware window. In a VMware window, we can see how the things, first we'll see the problem and later on we'll go with the other things. Coming to the problem here, right? Yeah, coming to the problem here, that is the next program. Yeah, this is the next program you observe. Yeah, fifth program. Simulate the different types of internet traffic such as an FTP and a telnet. Here instead of telnet, we are going to use the CBR. That is FTP and CBR different flows we are going to take over a wider network and analyze the packet drop and packet delivery ratio in the network. Very simple. You can see this particular topology as if the topology is here, same like that we have to create an bell topology. Observe carefully here, the 0th node is here and 1 node is here which is connected to 2 and 2 to 3 and 3 has been connected to 4 and 5 and 5 has been connected to 7 and 4 has been connected to 6. So like this, in this particular shape, we have to do an topology and we'll fix like this 0 to 6, let it be TCP flow, that is FTP flow will be there, and for 1 to 7. So let it be UDP flow, that is CBR flow will be there. After doing this particular thing, they have given very clearly the description here, that is node 0 is in a TCP source and the corresponding sink is at node 6 and node 1 is in a UDP source CBR traffic with a full agent attached to the node 7. These two traffic flows through the common link. This is a common link which is called 2 to 3. The aim of this exercise is to explain how TCP and UDP share the bandwidth between themselves. When the rate of CBR traffic is changed, set the TCP packet size to 1460, where including a header, it will become a 40 header will be there, no? So it will become a 1500 bytes. The UDP and CBR packet size sizes are 1500 bytes equal. All the links in the network have the same bandwidth, that is 4 MB. So you have to fix for 4 MB delay and the queue types will also be same. So everything you have to make it as the same, and then we are going to see how a contribution of means how the TCP and UDP will share the bandwidth with themselves. So that thing we are going to see in this particular thing. Sorry, just go back. 1 minute, 1 minute. Stop. Share again. 1 minute. Just somebody disturbed me. Admitting. Just I'll back here again. Share. Yeah. Now again coming over here. So in this way you have to do the things. This entire thing is a problem in textbook means in syllabus also they have given very clearly. After doing this particular thing, we have to check how many packets has been dropped. Means total. Analyze the packet drop. So we have to check how many packets has been dropped and packet delivery ratio means how many packets has been sent at a source and how many packets has been received at a receiver. So that ratio I have to tell. For example, 1,000 packets rised there, and then here only 800 packets has been received. That is 80%. So almost all packet delivery ratio will comes under. So 80% ratio, that is 10 is to 8. So that particular ratio we are going to get. So that is a packet delivery ratio which we have to calculate. Now coming in depth of this particular program, we'll go with the program, right? Just I'll go here. What is this? Yeah, NSG. So we have you have seen the topology. We have to set that particular topology here. It's loading. Yeah. It's taking time. Something like that. Just a minute. Yeah. I'll tell that. Yes, done. Now come here, scenario. We will go with a wider scenario, right? And notes. As there, according to the syllabus, we have to do this. Node 0 and node 1, right? Node 2 will be there, and node 3 is here, and node 4. Am I right? Yeah, node 4 is here, and node 5 is here, and again node 6 is here, and node 7 is here. So in this way you have to create a nodes first, then you go for an link here, that is a duplex link, correct, drop tile queue, correct, and capacity they have told you have to give 4 mbp. Yes, it is fixed, and size means delay is common for all, and we'll reduce the queue capacity to 20, means queue size to 20. Now for all the links it is same, they have told. So now we'll fix this N02, N2, N12, N2 same, coming to N2 to N3 it's same. Now again here from N3 to N5. Now again here from N3 to N4. Now again from N5 to N7, and N4 to N6. Same. Now you have seen here all the links is duplex link with a queue type of a drop tile queue and 4 Mbps of bandwidth will be there and 10 milliseconds and queue size will be 20. For all the links we have given a same thing. Now coming to the next, there must be a two flows. One is an TCP flow and another one is a UDP flow. What they have told TCP flow from N0 to they have taken clearly N0 to N7. They have taken N0 to N6 or N7. We'll go to the manual. Once again, we'll check the question. 1 minute. Just below. Yeah, you observe here, they have told here very clearly TCP and UDP, which will be there. Yeah, you can see here. So N0 to N6, it should be TCP. N0 to N6, it should be TCP. N1 to N7, it should be UDP. Now come back here. So N0 to N6, this is N0 and this is N6. It should be a TCP flow here. Now go back to the agent. Now here TCP, and I have told very clearly that the packet size should be 1460. Why? Because including 40, it will become 500. So I changed it there. Now observe carefully here. So I'll drag here and I'll keep right. So this is a TCP, and you know that TCP source N0 means TCP at a destination, it should be TCP sync. So it is the sync. So come here and I will put here, right? And we should connect from virtually from TCP 0 to sync 1. Don't forget this. This step is very much important. Now come back to the application again. Now if TCP is the source, FTP is the application agent, we know that, and the time will make it to start from 0.0 and let it be from 24.8. So we'll fix this. Then again what we are going to do, click here, drag here and place the FTP. Now everything it has been done. So now one connection is over. Come to the next connection. Go back to the agent. The next connection is from N1 to N7. So be careful there, N1 to N7. So coming over here, now it's not a TCP agent. They have told very clearly that is an UDP. Then the packet size they have told very clearly that is 1500. No need to set here. You can set there CBR also, not a issue. Okay, let it be here. So now I'll take this and I will drag this. Okay, UDP is ready here. Coming to the next here at a destination. If UDP is the source, at a destination it must be null. So destination is N7. We have know this. Then click there and fix the null agent. Once it has been fixed, you should connect from UDP to null. Virtual connection you have to do. That is important. Then coming to the application agent. If UDP is the traffic agent, the application must be CBR. Let it will start from, you have to click and you have to do. Let it will be start from 0.0 and let the time is 24.8, same I will give, and packet size they have told very clearly it will be 1500, and the rate you don't fix any rate here, let it be 0.0, let it share how much it wants. Okay, now it has been done, I think. Right, now you attach that CBR, click, drag and place the CBR. Done. Now we have connected, I will repeat, we have connected from N0 to N6. That is a TCP connection is there. So via N2, N3, N4 and N6. From N1 to N7 there is a UDP connection via N2, N3, N5 and N7, where N2 and N3 is in a common link or a common path between for the two sources. That is an important point here. Coming to next parameters here to fix, as we know that we our simulation we planned for 25 seconds, and then the output file will be of two types, as you know already. The tr file, let it be prog5, as we are doing from last programs, and then here let it be prog5, right? NAM file, animation file. Then I will tell done. It's done. Now generate a TCL script. Click on TCL. So once if you click on TCL, a TCL script will be generated automatically. This much code it has been generated. Don't forget to save. Save this. As you know, we are saving according to the program5.tcl. Save this as a .tcl file. Save. Now once it has been saved, now work of NSG has been over. Now close this. Yeah, close this. Go back to the terminal. Then from beginning I'll do right. Now go back to that particular program. Gedit program 5.tcl, you type enter. Now observe, this is a code which we had generated using a NSG. Now whatever small changes and cross check you can do with this particular thing. So time we know that we have fixed for 25 seconds, correct. NS simulator, right. And trace file is prog.tr and prog5.nam, it's correct. How many nodes total? We are going to take 8 nodes, it is also there. Now check the connections once. 4 MB, it's commonly taken, correct. N0 to N2, N0 to that's a queue limit, N1 to N2, and then N2 to N3, and then next one is N3 to N5. Am I right? Yeah. Next coming to N3 to N4, then N5 to N7, N4 to N6. Almost all connections are correct. Then orientation is there. Don't worry about that. Now this is cross check you have to do. TCP. Am I right? TCP has been connected to N0, correct, and destination sync is connected to N6, correct. Now TCP packet size 1460 we are taking, 40 header size it will become 1500, our intention, correct. Now coming to next UDP, UDP is connected attached to N1, right, correct. Now destination null has been attached to N7, it is also correct. Now coming back to packet size, we have set here 1500, but actually we have to set in CBR. Now come over here and you check FTP, it has been attached to TCP, it will start at 0.0, 24.8, it will end, stop. Now coming to the CBR, as you know that the packet size we are setting to 1500 and rate is 0.0 MB. We are not fixing a rate here. Let it take according to the demand. If we fix, what happens? No, there will be no effect of UDP on TCP. That's the thing. Why? Because if I fix 2 MB, out of whatever 4 MB is there, 2 MB will be fixed for UDP. Another 2 MB will be keep on using by TCP. That will be not good. So that's why here I am not fixing the rate for a UDP. Then interval must be there here. Where is the time interval? See, interval is not there. So interval is very much important, as you know, already have told you. So that's why while doing an analysis, sometimes one or two statements it will miss. $CBR set interval underscore 0.05 0.05 0.005 or 0.05 listening 0.05, let it be, we'll check. Coming to the next, so random null it's taken already, it will start at done. So termination finish function is there, it will call. Now everything is correct according to me. So once so color, we have forgotten the color, right? So otherwise distinguish between UDP and TCP will become a problem. So color I will set here. So dollar NS color. So as usual, one will be for a blue, and dollar NS. So color, two will be for red. So then go back to the TCP and UDP. Yeah, TCP, sorry, go back to the TCP here, right? So you can do here only, or wherever you want you can tell within that particular TCP, that is dollar TCP 0, that's a object set class, sorry, CLASS, class underscore to 1 for blue, we have set like that. So let TCP for blue. Then I'll go here with an UDP, dollar UDP, what is that name, 2, right? That's the object. Now we are going to set class underscore space you give. So what is that, 2 for red. Now you save this. So now our color setting is also over. Now the corrections, everything we have seen for a TCL script. Now you run this and we'll check. So program5 dot TCL, enter. There is a error here. What's the error? Interval it's setting error. So set, yeah, interval it's giving an error. So I'll cross check interval once. Come over here, come over here. Now come over here, 0.05, I think. Sorry, S capital letter I have taken, so that is wrong here. Set. See how beautiful it is. If single letter is wrong, it never tells you. So then close this. So come back, run the program. Yeah, now no problem, we got the things. Now according to orientation only it is there, given topology you can see there. Sorry. Now I will run this particular program, and you can see in the from one it has been started first, UDP red color, and TCP is a blue color. Why? Because acknowledgement is coming back. You can see that particular thing here. So in this way we are running. Now common 4MB is common here, and we are seeing everything, how the packets is taken and how the things is going. Here nothing has been dropped also, still now we are seeing. So drag this. So no drop is there. Right. Doing, if all you will take, no drops will be there. I'll show you that. Now we have done our work. So we are now with the TR file. So what we have to do according to the problem, we have to go with the two things. The one is the thing, how many packets has been dropped, that we have to see here what they have given. Why analyze the packet drop and packet delivery ratio. So these things we have to do now. So for this the TR file is needed, you know that. So we have to do a AWK advanced filtering we have to use, and then we have to extract the data and we have to do the remaining things. Just for this, yeah, drop packets. Okay, right. Yeah, I'll take my phone. Control C. Go back to terminal. This terminal here. Yeah. Now clear that. First, I'll do like this. Program 5 drop. Why? Because two AWKs. Program 5 drop AWK means for drop control V. Now I've taken two things here. After end, this is a PDR, right? Control X. I'll take a new one. Paste it. Done. No need of this. It will give you an error. I'll explain it. Not a need. Done. First we'll go with the drop, and later on I'll explain what this one. Now begin. As you know, AWK three parts will be there. One is the beginning, end will be there, and body of the AWK. Now we have taken a two variables here. Count is equal to 0 and count 1 is equal to 0. Why? Because how many TCP packets has been dropped and how many UDP packets has been dropped. That we have to show. That is our intention. So here, what according to the program we are going to do is, so we have taken easily this part 3, and here in a if statement, if $1 is equal to D, means it's showing that a packet has been dropped, and the type of the packet, $5 will represent always type. If type is equal to TCP, and here the comments, once you check between the notepad and this is very much here, that's why it will give you an error sometimes. So yes, you have to change this. Here it has been changed. Now see, this codes is not correct codes. Now here CBR, here not UDP, you have to take CBR. Why? Because in your trace file it will be only TCP and CBR types will be there. That you must be very clearly. Now this flower brace is missing here, means you can't put here. Just I made it wrong because to learn for students. That's it. So just I'll delete. I'll back here. Yes. Two if statements, single statement. No need of flower braces. This is the starting of a body and ending of a body is there here. So the TCP packets will be there in count, and the CBR packets drop will be there in a count 1. So coming to the end here, so I'm printing number of TCP packets dropped is count, and number of UDP packets dropped is count 1. So this program is correct. So the drop of the packets will be correct, and we'll back here and we'll check once with a PDR. I'll save this first, later on we'll come with a PDR and we'll check, not an issue. So program 5, for this I'll take a PDR dot AWK. Save this. Now leave it. I'll explain you later about PDR. Now drop your scene. Once again, I will very clear you. I have taken a two count variables to track how many packets has been dropped. Why two variables? One for a TCP and one for an UDP. And the type of a packet you can see here. Sorry, you come back here. Yeah, you can see here. So two variables I have taken, and if $1 is equal to D, means the type of a this one plus minus RD. D means drop of a packet. So at what time it's dropped, everything. Column number 2 will represent time. Column number 3 source, and column number 4 destination. Column number 5 type of a packet. Column number 6 size of a packet. So column number 5 is type. So TCP type, if it is dropped, I'm incrementing the count variable. If CBR means UDP, here we are not taking UDP, CBR you have to take. So CBR drop is there, then we are taking the count 1 plus. Finally, we are displaying the count here. Just I'll close this and we will see the work here. Now I'll back AWK option F. So program 5 drop dot AWK file name, input file you have to give. We know that input file is program5.tr. So that's a file. Enter 0. We doesn't observe even in animation also, we never observe any drop of a packet. So therefore number of TCP packets dropped is 0, number of UDP packets dropped is 0. For this what you have to do, you have to change the middle one, that is 2 to 3 bandwidth, whatever is there, you have to reduce that particular bandwidth. Then you will observe the drop of a packets. We'll reduce and we'll check it once. Go back, yeah, edit the TCL program, go to the connections here, yeah, come back here, 2 to 3, 2 to 3, it's a 4 MB is there, I will take it as 0.1 MB. Just 4 MB inputs is coming and 0.1 MB. I reduced 4 times of less, almost all. Size, let it, queue size, let it be 20 only, not an issue. Close this. Now, run again your TCL script. Yeah. Now, running. Yes, you are running. I'll make it somewhat fast. Yeah, drop occurred. Now we'll see how many TCP is dropped and how many UDP is dropped. You'll get an idea. Just I'm making fast. This is just animation. TR is important for us. Means TR file is important. Now again you run that AWK file. Right. Now you see here. Same drop it's there. That is number of TCP packets dropped is 284 and number of UDP packets dropped is 284. That means both TCP and UDP are equally sharing the bandwidth. Now we will go for a PDR and we will check how a packet is any packet delivery ratio is different from the things. Now I'll go back to that particular AWK. We know that that is we made the name as program 5-PDR.AWK. Now I'll open this. Now you can check this. Here also two variables we have used in a begin, count and count one to track TCP, to track UDP. Very simple. Now if $1 is equal to yes, yes will not be there actually to say. So always how we are doing the things, how many TCP packets it has been sent and how many UDP packets, how many TCP packets it has been received. So based on that particular concept, we are calculating the PDR ratio, right? Now we are actually in this particular program, some mistakes are there. So S will not be there. According to us, only plus, minus, okay, plus, minus, R and D will be there. So that's why what we are going to do here, I will take this as a plus. Yes, let it be. And column number 3, I'll take here column number 3. 3 is source, correct? No. So source should be equal to which is the source for TCP? 0. Yeah, correct. Then type of a packet should be TCP. Correct. Back here. This is the type. Sorry, delete. And size you have to take always, it should be greater than or equal to 1500. Why? Because acknowledgement, only acknowledgement will be there, that is only 40. You shouldn't take that. Because of that particular reason, $6 is greater than or equal to 1500 is must and should need it. So how many TCP packets sent we are calculating first. That is TCP sent is equal to TCP sent plus $6. So that is a one thing which we are going to take. Then afterwards, what we are going to take, sorry, delete this. Yes. Next, how many received at a receiver end, that we have to see. Now the $1 column will become a receive, type will be TCP before that, which is a receive node, that you have to tell, that is missed here. That is $3 should be equal to, what is the receive? If 0 is a source and destination is 6, we know that, right? So then yes, $5, let it be the TCP type. So delete. And size should be greater than or equal to 1500. Then you add that. So here what we are doing, how much user has sent, we are summating that. Then how much receiver has received, we are summating that. The summation will be there in TCP sent and TCP received. Coming to the end here, you can see here print the packet delivery ratio PDR TCP packet is I'll remove this, yeah, is comma TCP sent divided by TCP received. How many packets it has been sent divided by how many packets received. So I think that's correct. That's correct. If you want to find a ratio, that's correct. PDR packet, how many packets received divided by sent, I think. So then that is correct. How many packets received divided by sent. Then you will get a ratio, means percentage. So 1000 packets sent. How much packets you are going to? Yes, yes. So then receive will be here. Just for a change I made, and sent you are going to take here. Sent. Now this is entire script is there for TCP checking. So which we had did. But what about on a UDP means how many, what is the packet delivery ratio of an UDP? Usually UDP packet delivery ratio we don't calculate. Why? Because UDP is not a reliable protocol. If external asks you, you have to tell this particular reason. UDP is not a reliable one. When the packets will be sent there at the destination, it will receive. No tracking of packets will be there. That's why the packet delivery ratio we are going to calculate only for this particular TCP flow or TCP traffic. Now, according to me, the program is correct. Here, TCP sent, how much amount of data we have sent. Receiver 6, how much it has been received. So, received divided by sent, it will give the percentage. That is packet delivery ratio. Then close this. Now run that. AWK option F program5 pdr.awk, then prog5.tr. Enter. Syntax errors where some flower base is missing. We'll check that. Back here, which flower base is missing?
Sir, extra flower bracket is there.
Yeah, extra flower bracket is in which have. Yeah, ma, correct. So done. Now I'll save this. Yeah, now everything is correct. Yeah, I'll save this. Now again I'll run this. Division by error, it's giving. Why? Because division by error. 1 minute. 1 minute. First, what we will do now, we'll go back to this program. 1 minute. I'll display that variables. You'll get an idea. What is that? Print TCP underscore send. Am I right? Yes, correct. Then print TCP underscore RECV. We'll cross check it. And close this. Run this. I'm not getting any break here. Is that entire one value? I think no value for the beginning one. So only receive it showing. One minute. Just go back here. So not coming into the queue, we'll say out. No, we have to take minus, I think. Moving out from 0. That's why it's coming 0. So moving out means dq. So now on this, again it's value of that cent, it's not displayed. At least 0 it has to show. No? 1 minute. What I will do here, TCP sent is equal to 0. Right. That I have not declared. That's why it's giving error, I think. TCP received receive is equal to 0. Right. TCP sent plus go back. Now run the program. This one is giving 0 sent. Why? Plus, if I put plus, close this. No, it's giving error. Now, if these things happens, what we have to do? That question arises. 1 minute, just we'll go back. Yeah, we'll go back. Gedit, you open. Sorry, proc 5.tr. Open this, not an issue. Now you can see the plus 026 only CBR plus 0 is there here. Type we have gone with TCP and the size should be greater than 1500. It is that. TCP only acknowledgement is there. If TCP more, now back here. Plus correct 0. What's the problem here? 1 minute. So column number 1 is type, column number 2 is time, column number 3 is source, column number 4 is destination, column number 5 is type, and this. Now go back to our program where you get a mistake. I think we made a mistake. Yeah, both I have given 3. That's a problem. See, 3 is column number 3 is source, and here I have to check this for destination. 4, 3 NQ 5 plus 1 greater than or equal to 1000. $3 $1 $2 $3 is 0, which is going out from that. So I'll take here minus. So save this, go back to the program, observe 1 minus big 5 to 7 it is there. That's not needed for us. Minus, yeah, minus is there here. I will highlight this. You can see minus 0 means the packet which is going out. That's it. So which is going out from 0. Either wherever it is going, either 2, 3 means if it goes to 2, definitely it will go in a path further. How much it has gone out, that is important for us. 1500. So R will observe once the R come back here in a R. So TCP R I want, 1 TCP R at least. Back. Yeah. Yeah. Here you can see it's at 3 TCP 6. Yes, it is at 6. Traveling all the way from 4 to 6. No, it's a R I want. R. Yeah. Here. Yes, here you can see receiving 1,500 bytes. So that's a one thing, right? So one thing, go back, go back. Now we'll check this programs. We'll check this programs. Why it is giving zero? And something mistake is there. PDR check variable TCP send TCP send plus $6. If you take a week, if you take a 1 minute, $4.46 here, just 8 plus ones check plus times 0 correct. Both TCP, yes, type is TCP only we need, correct. We are checking TCP and size is greater than equal to 0. So see this correct. Close this. It's coming 0 1 to track this. It's not
semicolon maybe.
Inama?
TCP sent equal to 0 semicolon ಇಡಂಗೆ in begin.
ಇಲ್ಲ ಅದೇನು ಆಗಲ್ಲ ಅನ್ಸುತ್ತೆ. ಸೆಮಿಕೋಲನ್ ಏನು ಆಗಲ್ಲ ಅನ್ಸುತ್ತೆ. ಅದ್ರದ್ದೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ನನಗೆ ಗೊತ್ತಿರೋ ಪ್ರಕಾರ ಅದ್ರದ್ದೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಬಟ್ ಎಲ್ಲ ಕರೆಕ್ಟಾಗೇ ಇದೆ, ಕೋಡ್ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿದೆ. ಪ್ಲಸ್ ಆಗಬೇಕು ಇಲ್ಲ ಮೈನಸ್ ಆಗಬೇಕು, ಇಲ್ಲ ಎಂಟ್ರಿ ಟು ದ ಕ್ಯೂ ಅಕಾರ್ಡಿಂಗ್ ಟು ಮೀ ಡಿ ಕ್ಯೂ ಇಸ್ ಡನ್ and we have seen some lines are there. It's not picking that lines. That is my problem here. It has to pick that lines. So $3 yes, and 5 this also we have observed, and the size also we have observed. Greater than or equal also we have given. No problem. Close this. I'll run once again. Just I'll track it. Just 1 minute. Yeah. Plus minus 0 I want. And the CBR is there. Yeah. It's 3. No, it shouldn't be 3, it should be 0. Yes, see here. This line is in. What's the problem? Then at least it has to pick at least 1 according to me. Correct? No? So minus is there here. First line we have told very clearly it's a minus. Yes. And 0, 1, 2, 3. Column number 3 it's a 0. Correct? So only that we want. And type column number 5 is TCP, that also we have to greater than or equal to 1,500. Done. What's the mistake here? What's the mistake? ಕೀ ಕೊಟ್ಟೋಗ್ರಿ ನಾನು ಮಾಡ್ಕೊಳ್ತೀನಿ.
ಕಾಲೇಜ್ ಕ್ಲೋಸ್ ಆಯ್ತು.
ಕೀ ಕೊಡ್ರಿ, ಕೀ ನಾನು ಮಾಡ್ಕೊಳ್ತೀನಿ.
ಏನ್ ಕೊಟ್ಟ ಮಾಡ್ತಿದ್ದೀರಾ?
So that's the one thing. than or equal to TCP. Why it is? At least it should take one, no? Why? This is a mistake. Double equal. Double equal. And here also double equal. And here also double equal. That is a mistake. Save. Now I think it will work. Done. So 0.428571. So that means you can say how much data it has been sent. So total bytes, 21,000 bytes it has been sent for a TCP, but received only 9,000. So what is the thing? What's the ratio it has been sent? So 0.42 means almost all 42% only it has been received at a receiver. So thus we have did this particular program. So just I'll stop this sharing, right? Just I'll close this. Yeah. Understood? See how a small mistake, how it made. For comparing, we have put only one equal, two equals is needed, no? For comparing purpose. So that is a simple mistake which we have did and we struggled. Okay? Got it?
Yes, sir.
Yeah. So then we got both the outputs. If you see this video, again you will come to know that how to do this particular lab even with errors. We did that small errors, no? Even how to solve that errors also, we will come to know that. So I have completed the fifth program also for you, and left out is only the sixth program. According to me, the sixth program you can't do in online. At least that spinning program we have to check parallelly with other coordinators, but somewhat it's difficult. I'll check it out. I'll ask HOD madam, can I leave that one program? Maybe she'll tell okay. So 5 programs of NS2 and 4 programs of part A, that is C program. So total 9 programs will be there for you for an exam, and record also you write 9 programs, not an issue. And everyone you have to submit a record. Don't forget that. Don't delay that. Okay, write in a sheets of paper. Output, if possible, you paste the NS2 output screens. Otherwise, you will tell the printer is not there and all. Just draw it. That's it. Take a pencil. Node 1, node 2, node 3, like drawing. Draw, drop. You show just like packet is dropping. That's it. That's not a big issues, right? So you do that. So output you specify with pencil. If you are doing a drawing means with pencil you do the drawing, and that will be good enough. Okay. Thank you very much. Thank you.
Thank you, sir.
Thank you, sir.